Hello and welcome to Cyber Skills Live. My name's Daniel and I'm a climate conscious engineer. You're joining Craig and I for this very special Cyber Skills Live. Now, Craig and I love everything tech and data. You're going to be using data science skills to help fight climate change.
That's right, and today we're coming to you from Glasgow, the home of the COP26 climate conference. World leaders are coming together for important talks about the future of our planet. Thank you for joining us. We have groups joining us today from across the world and across Scotland as well. This is your chance to learn about data science skills and climate change in the classroom. You're about to get hands-on with data. So what is data? Well, data is information. It's things that we know. It's things like facts or numbers, things that we can measure. And data science is being able to collect that data, being able to understand it and use it to make decisions. We need more people who understand how to work with data and how to use it to make better decisions. But can we use data to save our planet?
We're in a climate emergency. To give us the best chances at reducing the impact of climate change, climate scientists have stated we need to secure global net zero by 2050 in order to keep the global temperature rise under 1.5 degrees. Now, to do this, we need to accelerate the phase out of coal. We need to curtail deforestation. We need to reduce our usage of fossil fuel transport, and we need to encourage investment in renewables. That's what we're going to focus on today, renewable energy.
You'll use real-world data sets to create a proposal for a renewable energy system for your school. You'll need to work with energy usage data, geolocation data, satellite imagery and Earth observation data collected by NASA.
So, are you ready to use data to save our planet? Let's plug in the numbers and use data science to reduce your school's carbon footprint. Thanks for joining us. We're really excited about this one happening during COP26. So as world leaders, delegates and activists debate the future of our planet literally around the corner from us, you're going to be data scientists exploring how renewable energy can reduce your school's carbon footprint. What you need to do now is go to cyberskillslive.com and click Start the Live Lesson.
Yep, all you need to take part today is a web browser. So head to cyberskillslive.com and click Start the Live Lesson. So once you've gone to the website, it'll ask you to put your name in and put your first name in and choose your school or group from the list.
So in this interactive lesson, we're going to be using data to answer this question. How much energy could a solar panel on the roof of your school generate? And also, what impact would that have on your school's carbon footprint? Every school taking part today is going to have a slightly different answer. We've already started to collect data about you, so we can see your names and I can see your avatars as well. And I'm going to share with you what we can see. So this is our activity field, and this is where we can analyze all of the data that you're going to send to us. So hello to David Aberdeen Grammar School. I can see we've got Oliver and Lauren playing from Birchgrove. At the start, we asked you all a question, and that question was, how did you get to school today? So we collected that data by asking you the question, and now we're going to analyze the results to try and understand what mode of transport is the most popular with all of you that are playing along with us this afternoon.
So one way that we can visualize this data and understand it is put it onto a chart. So this pie chart is an example of data visualization. So rather than me or Daniel just reading a list of what people have voted, we can show you the results on a chart like this, which makes it easier to understand.
So it looks to me that about 3/4 of all of you playing along today either walked or ran or rolled your way to school. The next most popular is the grey segment, and that is by car. So it looks like walking and the car are the most popular. At the other end, only one person has taken the bus to school, Craig.
Interesting. That is interesting. You think of more people would be getting the bus. But the thing is, Daniel, this is live data. So as people are playing the activity as well, those numbers will be changing and updating as well. We've been collecting some other data about you as well. We asked what it is you do for the environment, and I'm getting some of your answers in right now. So David has mentioned that he recycles quite a lot. Ruby, she's from Birch Grove, and she's going to start walking and not driving every day. I think if you're at a primary school, maybe you shouldn't be driving. I don't know if you can get your license for that yet, Ruby, but I'll take your word for it.
I can see here that Ella has been walking as much as possible and planting seeds in their garden, and they try not to waste food, and they turn off lights when they're not in the room. So the first part of our investigation is to work out how much electricity do we need to supply to your school? How much electricity does your school use every day or every year? Now, we could get that data a few different ways. You could look at the electricity meter, or you could even ask your head teacher to show you the electricity bill. And that'd be one way that you could find out the amount of electricity used
good luck
at
with
your
that.
school. You never know. But that would take too long. You might not even be given the data that you want. But as data scientists, we can learn how to work with data sets that will tell us what it is that we need to know. Now, we did a bit of research into how much electricity schools use, and it turns out that most schools use a really similar amount of electricity, at least within the UK. And there's data sets available with really detailed information on electricity usage.
So let's use smart meter data to give us an idea of how much electricity a typical school might use every year. So the data that you're using today is real data that has been collected by Dundee Council, and it's been shared so other people can use it. And that's the real life data that you're using right now. And because that data is available for anyone to use, it's called an open data set. So Daniel, why is it better to use an open data set rather than all of us trying to work out how much each school would typically use in a year?
Yeah, it's a good question. I think the main reason in this case that it's a good idea to use a data set is to save us time. You know, if you were going out and buying equipment and installing it and setting up, you'd have to leave it there for a whole year to count how much electricity was being used on that meter. Now, Craig, I can see quite a lot of people have been looking at the data set. They've been opening it up and they've been taking a look at the graph to see how much electricity gets used every day. I think it'd be a good idea if we bring that up just now and take a look at it.
Sounds good to me. Let's have a look.
Let's have a look.
So what is this that we're looking at here? Well, this is a chart that is showing us the electricity used at Braveview Academy. And you can see that it's clearly going up and down. Like, it looks as if on certain days of the week, it's higher than other days of the week. So as data scientists, we need to be able to analyze this data, try and get an understanding of why it might be doing this, what's going on here. So Daniel, the question here was, why is it higher during the week and yet it's being used less at the weekend? So the good news is we've got some of our participants here have started answering this question. Thomas has suggested that he's seen that every Saturday and Sunday, the energy used is much lower. And that's true. I can see that as well. Connor has mentioned that they could be off on the weekends, so the school isn't running at the weekends.
We're going to think a bit about where that electricity comes from. Your school probably gets its electricity from the grid, and the grid is a massive network of power cables that link the country together. The grid is powered by lots of different sources of electricity, things like wind, gas, coal, nuclear, and solar energy. I'm going to bring up the energy mix, as it gets called, and this is live data. This is a real dashboard, and these gauges show the proportion of electricity coming from different sources.
So I can see at the top left, Daniel, that pink gauge. That means that there's, quite a bit of wind power in the UK at the moment, and actually, looking out my window right now in Glasgow, I can see that might be true as well. So in this phase of the investigation, you're looking at solar energy. So the question that you're trying to answer is, how much sunlight do you get at your school's location? We need to know how much solar radiation your school gets.
We could use another data set. So NASA collects loads of data about planet Earth using their satellites, and they've got a data set that will tell us how much light falls on any location on the planet across a whole year. So if we send NASA the latitude and the longitude, so the coordinates of your school, they're going to respond with the data that we need. So what you need to do first is find your school on the map. And once you've found your school on the map, or you've even just found the town that your school's in, click on the building and it will drop a pin and it will show the coordinates at the bottom of the screen, ready for you to submit them.
I can see that Eva and Ella and Lydia, they've been pinpointing their school on the map. That's brilliant as well. Well done to Leon, who's also working that out as well.
So I'm going to bring up a few of
can you show me some, because I'm interested
yes.
here.
So here we go, here's one. Now this is Craighead Primary School, and this is the amount of sunlight that arrives on a 1 by 1 meter square of land at their school's location. So this is the real data for 2020.
It's brilliant. So I can see here that the higher the line is, the more light that they are getting as well. So I can see that May seems to be the month that Craighead Primary School are getting the most light as well, or it's certainly that it's reaching their school. That's the amount of solar radiation. Initially, I would have thought, Daniel, that June or July or August would have been the months with the most amount of light. Why is May sort of got a higher amount?
So I think it's a bit higher in May because May tends to be a drier, a less cloudy month on average than June or July tend to be. So although we maybe get some more daylight hours in June than we do in May, it tends to be cloudier. And this API, this data set from NASA, it even takes into account the weather in the clouds. So it really is the light that actually hits the ground at your school.
Daniel, we're almost there. I can see that some people are already calculating the size of the solar array for their school. So how big are they going to make it? Now, if you were doing this manually and you wanted to work out, how big an area, say you wanted to put it over your school roof, you would have to, how would you go about measuring that normally? You would have to climb up onto the roof with a trundle wheel, and you'd have to walk along the very edge and measure it all out very slowly. But we're technologists, we can use geographic information systems to help us with that. So in this activity that we've made, there's another map, and what you can do with that map is really interesting. You can draw a shape around the roof of your school, and that will tell you the area, the size of the solar panel that you can make as well. So what you're going to do is click on the edges of your school to draw that.
Once you've got that area, we've got one final calculation for you to do, and that's going to answer the question of how much electricity could be generated by a solar panel on the roof of your school.
To do that calculation, you're going to multiply the amount of electricity for 1 by 1 meter square and times it by the total area. That will give us the total amount. Daniel, are we getting in some submissions? Daniel, let's see some of these results.
Yeah, let's have a look at some of the stats that are already through. So here are the numbers for St. Joseph's Primary in steps. So you calculated that solar panels could generate 225,000 kilowatt hours of electricity over a year. Well, what does that mean, Craig? What does that mean?
Daniel, that means that would be enough to charge nearly 19 million iPhones in a year. That's a lot of electricity.
Yeah. Let's take a look at another one. So this one is Highfield Secondary School in Jakarta. 105 computing classrooms for a year. So that's a bit more. There's just a bit more solar energy available in Indonesia. But yeah, and let's have a look at one more. So this is the numbers for St. Paul's Academy in Dundee. And they've worked out that they could power 27,362 light bulbs continuously 24/7 for a year.
This is brilliant. We're getting so many results in here, and it just shows you that the solar energy potential, even in Scotland, because I think a lot of people would think, Scotland isn't very sunny.
Craig, I've been looking at the numbers coming in, and we've got results from 20 different schools
Okay.
Yep, the 20th one just came in. So if all of those schools installed their solar panels that they've just described, so we've taken one pupil from each school, and we've worked out collectively that you could power 69,406 light bulbs for a year.
Yeah. So what was that number again?
69,406 light bulbs.
Okay,
I've got a graphic that
let
will
me type. I
illustrate
was going
them.
to say, let me type that in for you, Daniel.
Okay.
We can use our tool to do that. So 69,406. Okay, to give you an idea of how many that is, that should be ready, Daniel.
Oh.
This is brilliant.
Thank you very much for, being part of our data science team today. We definitely couldn't have done it without your help. You've given us the data for 20 different schools, and I hope this has got you thinking about how we can use data to reduce the carbon footprint of your school or of other buildings as well. Thank you very much for joining us today. I hope you enjoyed it. I hope you learned something, and I hope that data science was fun and exciting for you as it was for Craig and I creating this activity. But for now, it's goodbye from Craig.
Bye-bye.
And it's bye from me as well.